Next, let us do a problem in which we have a dependent source and we need to find out Thevenin's and Norton's equivalent. Now, Thevenin's and Norton's equivalent both may not be asked. In this particular question, they have asked to find out both Norton's equivalent as well as Thevenin's equivalent. In reality, you may be asked to find either one, either Norton's equivalent or Thevenin's equivalent. Whatever be the case, the steps are the same. And to simply write the steps are: 1. Use the method to find VTH. Second, find find the current, Norton's current, IN. And third step is find find RN, which is same as RTH, which you can find out by doing VTH, which you have got here, divided by IN, which you have got here. So originally we need to solve the problem only for finding VTH as well as IN. So let us do it. So step 1, find VTH. So we know that the circuit diagram for finding VTH is that we keep it as open circuit. The same diagram we can use. The diagram is here. Let's name this current as IX, because already here I1, I2 is named, that's why I'm using IX. Here I could have drawn a current, but I cannot draw it here because this is open. So I cannot draw a current here. So actually there is only one mesh here. And from this we need to find out the VTH, which is across this one, VTH. Now already you can see that here the voltage is not going to be there because there is no current flowing here. So you cannot write anything. So this is 0 volt because there is no current flowing. Whatever you have to find out with the help of finding I1 and I2, because the voltage here is 10 I2, the voltage here is plus minus 5 into I1, and here it is 3 times I1, and here it is, I already told you, it is 0 volt. So first we need to find I1 and I2. So from here I can say that Ix, because Ix is moving in this direction, I can say that I2 is same as Ix, correct? I2 is same as Ix, and since Is is moving like this and passing through this branch, it is minus I1. I1 is going to be minus Ix. Now you might be asking, why is there no other current flowing here? Yes, there is no other current flowing here, because if this terminal would have been closed, AB would have been closed, I could have said that there is another current here. But AB is not closed, so there is no other current flowing. So I2 is basically Is and I1 is basically minus Ix. So now let us write the KVL. So KVL at mesh 1. KVL at mesh 1. So we will see from the flow of Ix, I can write this is plus minus. This is again, Ix is flowing like this. This would be plus minus. This is already plus, already the polarity is given. So let me take the front of the component. So 5 plus 5 minus 10 I2, which is Ix. Then Ix is flowing in this direction, that means that y plus minus, out of which front of the component means minus 5Ix. So minus 5Ix. Then we are having minus 10I2, minus 10I2. But that is equal to 0. But I2 is equal to, already we have seen I2 is equal to Ix. Therefore, this equation becomes 5 minus 15Ix minus 10 ix is equal to 0, from which I will get, therefore ix is going to be equal to 5 divided by 25. Clear? So 5 divided by 25, I will get whatever is the value of ix, which we will get it as 1 by 5, which is 0.2 amperes. So we have found out ix. Therefore, we have found out already I2, thus I2 will be equal to zero point 0.2, I1 will be equal to minus ix, which is minus 0.2. So now KVL at mesh 2. KVL at mesh 2. So KVL at mesh 2, if I am going to write, so let me write from here. So the current that is flowing is, I can write Ix or even I1, it does not matter. Let me follow like this. This is 5 I1, this is plus minus, this is 0, this is 3 I1. So let me write from the front of the component 10 I2. So I will write 10 times plus 10 times I2 minus 5I1 plus 3 times I1 plus 0 minus VTH is equal to 0. Already I1, I2, we have already seen that I1 is 0.2, sorry, I2 is 0.2, I1 is minus 0.2, so I can write this as 10 into I2 is, or let us, okay, 10 into 0.2 minus 5 into minus 0.2, that minus and minus will become plus, into 0.2 plus, plus 3 times minus 0.2 again I can write it as minus 3 into 0.2, okay, is equal to VTH, or together if I am going to calculate, this will come as, let me look if I made any mistake. So this is 10 I2, no issue. This is okay, so everything is correct. We will get VTH is equal to 2.4 volt. So we have found out VTH. So the first step is over. Second step is to find IN. For finding IN, we will use the same diagram. Let me rub all the other marks here. So let me say this is not there. I will keep IX. I will take out all the other marks. Okay, so I have got again the circuit fresh. You need to actually draw the circuit again, but this time you all know that for IN we have to consider A and B short, and the current that is passing through here is IN. Therefore this is IN. Okay, I will rub this one. There is no VTH. So now this is correct. Okay, now for this one, let me do the mesh analysis now. So mesh, not mesh, KVL at mesh. Therefore KVL at mesh 1. So KVL at mesh 1, so Ix is flowing like this, so this is plus minus, already this polarity is given, so I have to write straight away plus 5, plus 5 minus 10 Ix. You already know Ix is not, please don't write Ix as 0.2 because this is of the previous figure. Now we have to write for the new figure. So don't consider this. This belongs to the previous section. It does not belong to the new. That means for finding IN, because for finding IN we have changed the circuit. We have drawn A and B as short. So now it is going to be different. So 10 Ix minus 10 Ix minus 5 Ix minus IN then minus 10i2 is equal to 0. Okay, now I2 is same as, look at the figure, you will find out I2 is same as, so I will write but I2 is same as Ix and I1 is same as Ix, sorry, In minus Ix. In minus Ix. You look at the direction, you will see In is flowing from top to bottom, or bottom to top, and Ix is flowing from top to bottom. So I1 will be In minus Ix. That is I1. So I need to substitute. Therefore, there is only I2 to be substituted. So I will write, therefore we get 5 minus 10ix minus 5ix plus 5in minus 10. Instead of I2 I will write Ix is equal to 0, or we can write 5 is equal to, from here I will get 5 is equal to Ix. If we add up all together and we take the other side, we will get 25 Ix, and 5in, if we take the other side, we will get minus 5in. This is the first equation for solving the simultaneous equation. Okay, now the second equation, for second equation we will go for KVL at mesh 2. Now KVL at mesh 2, if I am going to write, so I have to write with respect to In, so this is plus minus, this will be plus minus, the current direction is such that this will be plus minus. So now let me write, the equation will be taking front of the component 10i2 minus 5in minus ix plus 3i1 minus 10 in, that's all, is equal to 0. Already I1 is in minus ix, so I will write, but I1 is equal to in minus ix, therefore I will get 10i2 minus 5in minus plus 5x plus 3. Now I will write, instead of I1 I will write in minus ix, so it will be in minus 3ix. Okay, because I1 is an in minus ix, minus 10 in is equal to 0. From this one you can very clearly see that there is no, what do you say, value as such. So it is 0 is equal to, let's, I2 I have not written, isn't it? I2 is already ix, so I better write this I2 as ix, that I had not written. So this I2 also becomes ix. Why? Because I2 is equal to ix. So I2 is equal to ix. So now I am having ix terms together, I can write, so 10 plus 5 minus 3, 10 plus 5 minus 3 is 12ix, and in terms minus 5 plus 3 is minus 2, minus 10 is minus 12 in, and that is going to be my second equation. Now using or solving both these equations, solving this equation as well as this equation together, that is a simultaneous equation, solving, we will get Ix as equal to 0.25 amperes, and Iy I will get it as, not Iy, sorry, In I will get it as 0.25 amperes. So as you can see, main important thing was In. So I found out In, I found out, already I have found out VTH. So now I need to find out what? I need to find out R. Therefore the third step is, so this was find in, so therefore Rn is equal to Vth divided by in, which comes out to be Vth is 2.4, this is 0.25, which basically comes to 9.6 ohms. So that is your Rn. So now based on this, what will be the Thevenin's equivalent? Okay, the Thevenin's equivalent will be a voltage source which has a value Vth, which is 2.4 volt, and the resistance, which is 9.6 Rth. Okay, Rn is same as Rth, that is the same as Rth. So it is 9.6 ohms. What is the Norton's equivalent? Norton's equivalent is the current source. The current source is IN. IN is basically given by 0.25 amperes, 0.25 in parallel with a resistance. What is the resistance? Which is Rn, 9.6 ohms. So by using this method, we can find out either Norton's equivalent or Thevenin's equivalent. So once again, for the case of dependent source, remember very clearly, for the case of dependent source, you first need to find Vth by keeping A and B terminal open, by keep A, B open. Okay. Similarly, for finding out the Norton's equivalent, you need to short. So for finding IN, short A and B. And based on that, you find Vth and IN, and Rn and Rth you can find out by basically dividing Vth with IN. So that's how you solve the problem.